The red giant star we know as Betelgeuse is one of the most extraordinary celestial bodies visible from Earth. If you were to place it where our Sun is, this enormous star would stretch so far across space that its outer layers would reach all the way to the orbit of Jupiter. That's how unbelievably massive it is. Betelgeuse is not just big, it is unstable. It is approaching the end of its stellar life, teetering on the edge of a dramatic transformation. In astronomical terms, it is about to explode, meaning it will one day undergo a cataclysmic supernova event. No one can precisely predict when this will happen. It could take thousands of years, or it might surprise us by occurring sooner than expected. When scientists joke that it might even explode during a broadcast, they are emphasizing the unpredictable nature of such stellar phenomena. Right now, a cosmic spectacle is unfolding before our eyes, drawing the attention of astronomers worldwide. Betelgeuse, a massive red supergiant star that marks the right shoulder of the Orion constellation, is changing in fascinating ways. Its brightness has increased significantly, rising by nearly 50% compared to its usual luminosity. At the beginning of the year, Betelgeuse was ranked as the 10th brightest star in the night sky, but now it has climbed to number 7. For such a massive and distant star to change its brightness so dramatically, something major is happening on or within it. Betelgeuse is an ancient, evolved star nearing the final chapters of its existence. Its size defies ordinary comprehension. To put things into perspective, if Betelgeuse were placed at the center of our solar system, its fiery, gaseous layers would engulf the orbits of Mercury, Venus, Earth, Mars, and stretch all the way to Jupiter. It is not just big, it is titanic. One day, it will reach its fate. Betelgeuse will explode in a powerful supernova. When this happens, the explosion could result in the formation of a compact but ultra-dense stellar remnant, such as a neutron star, or possibly even a black hole, depending on the mass of its core. What makes this event so exciting for us is that Earth occupies a perfect vantage point to witness the show when Betelgeuse finally goes supernova. At approximately 650 light-years away, Betelgeuse is close enough to put on a spectacular visual display, but far enough that its explosion poses no danger to life on Earth. The light from its death throes will take centuries to cross that immense distance, meaning what we see will be a glimpse of something that actually happened 650 years ago. When the star explodes, it will outshine nearly every other object in the sky, becoming a cosmic beacon unlike anything we have seen in modern history. When Betelgeuse does go supernova, the first signal we will detect will not even be light. It will be an intense burst of neutrinos, those elusive subatomic particles that pass through nearly all matter undetected. Shortly afterward, the explosion's visible light will pierce through the surrounding dust and gas, transforming the star into a blazing spectacle. It will become up to 100,000 times brighter than its normal state, potentially rivaling the brightness of the full moon. Some predictions even suggest it could be visible in daylight, shining as a second sun. At night, it may illuminate the landscape so strongly that it casts shadows, a surreal phenomenon that will last for weeks or even months. This bright display will not fade quickly, allowing scientists ample time to study the event in detail, gathering critical data about the life cycles of massive stars. Despite the dramatic sound of the word supernova, there is no reason for us to worry. Betelgeuse is far enough away that its explosion will not harm our planet. Instead, we will be privileged observers, watching a cosmic story unfold from a safe distance. But to truly understand why Betelgeuse has captured such intense interest recently, we must look back to late 2019, a time when the star began behaving in ways that baffled astronomers. In late 2019, Betelgeuse began to dim in a manner unlike anything previously observed. Its usual bright, fiery presence faded noticeably, and the change was visible even to the naked eye. People without telescopes could look up and see the difference, an unusual situation for a star of this scale and prominence. Scientists quickly turned powerful telescopes toward Orion to investigate, using instruments capable of capturing extraordinary detail. One such instrument revealed that the surface of Betelgeuse, called the photosphere, was undergoing dramatic changes. The outer layer of the star appeared to be expanding, almost as if Betelgeuse were puffing up like a balloon. This outward movement of stellar material continued for much of 2019 at an astonishing speed of about 8 kilometers per second. However, something shifted in November of that year. The star seemed to stop pushing material outward, and new high-resolution images revealed a mysterious dark patch forming on the southern hemisphere of the star. As a result, Betelgeuse's surface temperature dropped by about 80 Kelvin by early 2020. During this time, Betelgeuse became the faintest it had been in living memory. The dimming alarmed both professional astronomers and stargazers alike, leading to rampant speculation that the star might be on the verge of a supernova. Yet, as 2020 progressed, the star gradually brightened again, returning to a more stable state. This left scientists with a burning question: what had caused this strange and unprecedented dimming event? After extensive observation and research, scientists concluded that the dimming was likely caused by an extraordinary phenomenon known as a surface mass ejection, or SME. An SME is similar to the solar flares and coronal mass ejections we sometimes see on our Sun, but on a scale so vast that it is almost unimaginable. In this case, Betelgeuse expelled a staggering amount of material from its outer layers. As this ejected material cooled and condensed into dust, it formed a veil that partially blocked the star's light from reaching Earth. This was why Betelgeuse appeared dimmer. The surface mass ejection observed on Betelgeuse was the largest event of its kind ever recorded. To put this in perspective, the star released about 400 billion times more material than what is typically expelled during a normal solar flare from our Sun. The mass of material thrown out was roughly equivalent to several moons combined. This marked the first time scientists had ever seen such a colossal event occurring directly on the surface of a star. Using the Hubble Space Telescope, astronomers were able to watch the aftermath of this event in remarkable detail, giving them new insights into how stars like Betelgeuse evolve and age. The eruption caused Betelgeuse to shed a significant portion of its outer envelope, far more than what it typically loses over the course of an entire year. In essence, the star ripped away part of its own surface, leaving it temporarily weakened and unstable. As Betelgeuse began to recover from this event, its usual patterns of brightness variation also changed. Prior to the eruption, Betelgeuse had a regular cycle of brightening and dimming that lasted roughly 400 days. After the eruption, this cycle was cut in half, with the star now oscillating every 200 days. These brightness fluctuations are caused by the star's outer layers expanding and contracting, which alters the amount of visible light it emits. Astronomers have identified two primary cycles in Betelgeuse's behavior, a shorter one lasting around 400 days, and a longer, more mysterious one that spans over 5 years. The 5-year cycle is not yet fully understood and continues to be a subject of study. To better understand the recent events, scientists turned to sophisticated computer models. These simulations suggest that a massive bubble of hot gas may have formed deep within Betelgeuse, eventually rising to the surface. When it erupted, it triggered the enormous surface mass ejection and altered the star's internal rhythm. As a result of this violent outburst, Betelgeuse's outer layers expanded while its inner layers contracted, leading to the observed shift from a 400-day pulsation cycle to a 200-day one. However, astronomers believe this change will not be permanent. Within the next 5 to 10 years, Betelgeuse's inner structure is expected to stabilize, and its regular 400-day cycle will likely resume. When it comes to the big question, when will Betelgeuse go supernova? The answer remains uncertain. Current models suggest that the star's explosion is still a long way off, possibly 10,000 to 100,000 years in the future. At this stage in its evolution, Betelgeuse is still fusing helium into carbon within its core. It will have to go through several more stages of nuclear fusion, burning elements like oxygen, silicon, and finally iron, before its core collapses and triggers the supernova. Only when its core becomes filled with iron, a dead-end element for stellar fusion, will the star collapse under its own gravity, leading to the violent explosion that marks the end of its life. Even when Betelgeuse finally reaches that moment, the explosion we see on Earth will be a delayed message from the past. Since Betelgeuse is 650 light-years away, any event that occurs there will not be visible to us until 650 years later. This means that even if Betelgeuse had exploded today, humanity would not witness the light from that explosion for more than 6 centuries. For this reason, it is highly unlikely that anyone alive today will see Betelgeuse